session is on examining climate change impacts and mitigation by SANDI, that is South Asian Network for Development and Environmental Economics. And this is a network which is doing great work, undertaking research and also capacity building among the young researchers in South Asian region. So you can get more information on SANDI through the website www.sandionline.org, and maybe the young researchers can log on to the website and get more information on the research funding as well as the capacity building. And during this session, all the 5 speakers are going to present the work they have done with SANDI grant, and these works cover the important countries of India, Pakistan, Bangladesh and Sri Lanka. So we know that we are going through a tough time, and World Bank predicts that the food prices will be further high, and we are equally concerned with the food security, or rather food insecurity. And these 5 studies that we are going to discuss basically deals with 2 important macroeconomic issues. One is what is going to be the impact of climate change on food production, food grain production rather, to be more specific. And second, there are certain policy measures which most of the South Asian countries have already adopted, and how these policy instruments are going to work, or how do they perform in the South Asian socio-economic conditions. So these 2 are the 2 important areas we are going to focus on, and maybe start with the impact studies first. So the impact studies, these 2 studies, one study was undertaken in the Punjab region in Pakistan, and the second one in more tropical conditions in the South Indian conditions in Tamil Nadu, and both of them focusing on the food grain production and of course the farm income, how the irrigated and unirrigated situation is going to be affected, how the small, medium and large farms are going to be affected. That's the question they are going to find answers to. And the second aspect, that is the policy instruments, like one is on the slash and burn agriculture, the policy decision towards forest conservation by the governments, and how the communities that depend on slash and burn agriculture is going to be affected, how the biofuel policy of Jatropha plantation is going to affect the food production, and how we can use the market driven instrument of say RED Plus for effective involvement of communities for afforestation programs. So each presenter will get 12 minutes for their presentation, and we will start with Dr. Abdul Saboor. He is the professor of economics in University of Arid Agriculture in Pakistan. He starts with his presentation on the impact of climate change on food grain production and farm income in the Punjab region. Dr. Saboor.
Saboor.
Presentation is on. Okay. Okay, I think it's all right if it is not working. I'm just exploring the impact of climate change on agriculture in Pakistan. But what we have heard in the last plenary session too, mostly the same things I need to tell you again. So it is a sort of recap, but everything which we are going to see here, that is obviously empirical and based on primary data that is collected from 27 districts in the Punjab province of Pakistan. Next please. just overview of agriculture, what we call the backbone of Pakistan's economy. It accounts for 21% to GDP, and 45% of labor force, 18% of export value, and around 60 to 62% of the rural livelihood that is engaged either directly or indirectly. So the major crops like wheat, rice, sugarcane, and cotton, they are accounting for 29% to agricultural value added, and this is actually 6% of our GDP. Next, please. So as we have heard a lot this morning that there is a significant impact of climate change on agriculture. So when we say that climate change, it means that there is a change in temperature, precipitation, and sometimes the temperature is further segregated into minimum and maximum temperature, and further segregation is made across different seasons in the year, like winter and summer. So what we observe that there is increase in the frequency and intensity of extreme weather in our country, erratic and changed timing of monsoon. So we are also facing changes in the freshwater supply. You have learned a lot about it. Shifting of production zones and increase in irrigation demand. And high temperature which is actually associated with the reduced crop yields. So smallholders, they have limited capacity to adopt as far as climate change is concerned. Next, please. Keeping this background in view, so there are a variety of questions that normally swing in the mind of researchers, like as you see on the left-hand side, what is the likely impact of climate change on major crops? So the area that has been less explored in Pakistan, and particularly by collecting primary data. How will small farms fare relative to that of the large ones? So are rain-fed farms more sensitive to climate change? So these are the questions which have been addressed in this study. So as I have discussed, that 27 districts were taken and primary data was collected by constructing a questionnaire well approved by national and international authorities. And we took 345 farms, and that 345 farms that were taken from these 27 districts, and across these districts we have 18 MET stations. So we synchronized the primary data, cross-sectional data, and we mixed it with the 18 MET stations. So climatic data was collected from the meteorological department, and 18 stations are available. So this is technique to stitch district level cross-sectional data to that of the MET data. So finally we assessed the difference in net farm revenue as a result of changes in the climate variables. Next, please. This is just a perception of the farming community. If you just look these bars, the percentage that has been given in yes terms. So when the question was asked to the farming community that whether the long-term shift in temperature has been noticed by them or not, so 95% they are saying yes. Similarly, among those adjustment made to the temperature changes, there were 35% farmers. So 83% farmers, they are saying that there is long-term shift in the rainfall, it was noticed. So only 23% adjusted that was made to the rainfall change. So the soil is going to be more fertile, 35%. So 95% farming community is saying that there is a significant impact of climate change on crop, and obviously we are taking major crops. So adaptation strategies followed by the farmers, they are 22%. Next, please. So the net farm revenue estimated for all these farms, a small segregation has been given across the scale and irrigated and non-irrigated farms.
this gives a very interesting thing, and that is quite matching to what the research is going on in the world, in South Asia, and very limited in Pakistan. Overall, we see that there is a good level of net farm revenue. It is around 1861. In case of small farmers, the average net farm revenue is smaller than that of other two categories. And the last two bars, if you just check the irrigated farms, they are getting more average net farm revenue as compared to the non-irrigated. So you can see that in this slide, you can just make a comparison that small farmers and non-irrigated farmers, they are at the hard hit. Next, please. So these are the key findings by employing a Ricardian approach. There are a lot of findings, but right at the moment I am presenting 3 findings with reference to the impacts. These are actually marginal impacts. So increase in Kharif maximum temperature has a negative impact. So we have seen that increase in winter and summer maximum temperature has negative effect. We have seen that rainfall is, leaving a positive impact, but this is exceptional case is that of summer rainfall. So winter rainfall, fall rainfall, and what you call spring rainfall, all are giving positive impact, but summer is giving negative impact. Next, please. So keeping these results in view, you understand that when marginal estimations are made, we can go for the thresholds. In Ricardian regression, this is a sort of nonlinear regression, and in nonlinear regressions, we might have a hill-shaped or a U-shaped structure. So you can find out the thresholds. This is very important. So this is the first time in any study these thresholds are being estimated. So the Rabi maximum temperature is 24.8 degrees Celsius, Kharif maximum temperature 36.7, Rabi minimum 12, and so on. So the rainfall, in case of Kharif rainfall, it is 56.6 mm. So that was the story of impact on overall basis. So there is a lot of work across the scale, small, medium, and large. So the distribution of climate impacts is small and unirrigated farmers, they are worst hit, because when we say that the Kharif maximum temperature is giving negative impact, that negative impact is across all the farming communities, but it is more in case of small and unirrigated farmers. So that is why I am saying small and unirrigated farmers, they are the worst hit. Then increase in fall and winter rainfall is positive for non-irrigated farmers. Again, it is quite relevant to what has been studied in the past, particularly in rest of the world, that when we increase the, this is fall and winter, which means for the Rabi season. So if rainfall is increased for this season, so the non-irrigated farmers, the farmers who are cultivating in rain-fed areas, so there is positive impact. So we have made a lot of segregation for all these estimations across crops, 4 major crops. So wheat and cotton farmers, they are at the losing end, wheat and cotton farmers. And this is, if you just check the link of, in case of Rabi and Kharif estimations, so this is quite significant. So remember, all these results, they are statistically significant, as well as the robustness check has been made, if you understand the simple econometrics. So sugarcane and rice farmers, they are benefiting. Last slide, I think. So keeping these few research, I'm just giving some policy message. So that message has been transmitted into 3 dimensions. One is research, other is extension services and investment, and the last one is farmer action. So as we have heard this morning, that there is a great debate of what sort of research needs to be made. So right at the moment, I believe that there is a need to make a research on new cropping patterns. So because it is quite clear, particularly in South Asia, including Pakistan, on the basis of this study and some other studies, I say that new cropping patterns are emerging. So there is a need to see what are those cropping patterns in different parts of this region. So there is a need to introduce heat and drought resistant crops. So we have talked a lot that there is a need to have some varietal development and sometimes the talk is moved to whether we should purchase those new varieties of new crops, or whether we should make a research at our own level. So in South Asia, fortunately, we have a very good institutional structure of research and development. The need is to, give more funding to that sector so that we can develop some new heat and drought resistant varieties of these major crops. Then extension services and investment. This is very clear in the study that by enhancing the spectrum of information diffusion, we can make a big change. And similarly, by improving our existing irrigation system, there is a sort of resilience that can be created against climate change. So farmer action is also required, so they can easily make some adjustment in the timing of cultivation, but that should be linked to the enhancing of spectrum of information diffusion. If that diffusion level is improved, obviously the adjustment of timing of the cultivation would be improved. So we have also learned of water harvesting and conservation, so that action needs to be taken by the farming community as well. Thank you very much.
I think we can take the questions at the last. Okay, so maybe you can note down the questions after each presentation and we'll take the questions at the last. And the second presenter is Dr. R. Balasubramanian. He is the professor and head of Agricultural Economics Department in Tamil Nadu Agriculture University in South India. And he is going to talk on the impact of climate change on the water resources, especially the groundwater and the well density, and how it affects the agricultural production. Dr.
Yes.
Balasubramanian.
Good morning, friends. So this study again was funded by the SAES, which is on climate change, groundwater table and farm income in South India. Next, where I am going to look at the impact of climate change on water table, groundwater table and its subsequent income on farmers in South India. Next. So the climate change has tremendous impact on water availability and use. So it affects both the supply side and the demand side of water use. The impact on groundwater is studied very least mainly because of the paucity of reliable data on groundwater fluctuation under the ground. And then the short run for response to decrease in rainfall and increase in temperature is to pump more water, more groundwater. So which will lead to, so in the short run, if there is a shortage of rainfall or something like that, the farmers are increase in temperature causing more evapotranspiration, the farmers will pump more water. But if they pump more water now, less water will be available in the future because the groundwater recharge is very limited. So that is another impact of climate change on groundwater. Next, long run productivity losses will occur due to depletion of groundwater over time. So on the right side you see the picture of a dry open well, and then next to that is the drilling of bore wells using modern technology, because nowadays the farmers start using bore wells because it is very expensive to dig open well as in the earlier times. Next. So we have the brief information about the groundwater usage in India so as to provide a background for and rationale for my study. So India is the largest groundwater user in the world. 60% of irrigation and 85% of the drinking water requirements are met from groundwater in India. Increasing instability in surface irrigation systems is also leading to growth in groundwater irrigation, and this will continue to grow in the future also. more than almost one-fourth of the blocks, roughly 30% of the groundwater blocks are overexploited in India already, and 60% will be in a critical condition by 2025 as per the World Bank estimates. Next. So here we have the carbon footprint. Groundwater is not only affected by climate change, but groundwater pumping also contributes for climate change, in the sense that farmers use electricity for pumping, which is produced by burning lot of coal and oil or whatever it is. So that way, pumping more groundwater using electricity also contributes for climate change, in the sense that in this picture we have given the increase in groundwater usage as compared to surface water usage. Say you see the surface water usage, that is in the blue color bar, so it is almost remaining stable over the next 50 years up to 2050, but the groundwater increase is that is the red bars, it is going to increase in the future in response to the stagnation in surface water availability. And this yellow line, which shows the increase in greenhouse emission, mainly caused by pumping of groundwater in million metric tons of CO2 equivalents. Next. So that way, so this map on the right hand side shows the groundwater hotspots in India, which are going to be affected very much by the climate change in future. One is the northwestern part of India, where you have these states like Rajasthan, Gujarat, and then parts of Haryana and Delhi regions. And then in South India also, the Deccan Plateau, and south of that we have the groundwater hotspots, mainly because of prevalence of hard rock aquifers in our South India. Next. So Tamil Nadu is the state that is located in southernmost part of India, very close to Sri Lanka, and more than 70% of our state's lands are underlined with low storage hard rock aquifers. So that means our groundwater availability is very low, but our pumping is increasing over the time continuously. As shown in the graph on the right side, you see the blue line, which indicates a continuous growth in area irrigated by the groundwater over time, whereas the yellow and white lines, which shows the surface water irrigation, so which is remaining stagnant or decreasing over a period of time. So in Tamil Nadu, the total water availability, groundwater availability is 23 billion cubic meter, that is 5% of India's total water availability, but more than 80% of this total water available is extracted in our state, whereas in India the groundwater extraction is only 56% of the total availability, which means in our state we are exploiting more groundwater than the whole of India. So that is causing a lot of over exploitation problems in groundwater, which means we are pumping more water than what goes inside the aquifers. Next. So in this background, we took the study with the objective of knowing or understanding how the groundwater recharge respond to climate variability. So we measure this impact by using groundwater level data available over a period of 40 years from 1971 to 2010 across the state, from about 1,750 observation wells located in different districts of the state. And also these data are available for 11 districts. So we have enough geographical variability and also enough temporal variability to understand the impact of climate change on groundwater. And the next objective is to find out how far this impact of climate induced groundwater fluctuation will in turn affect the farm income. So that is again we use the farm level data that we have collected over a period of 40 years in one of our Government of India funded research projects on cost of cultivation of principal crops in Tamil Nadu. So these data are again available for all the 11 districts over a period of 40 years, the same period. So we could generate 440 observations or panels. So this is a panel data analysis, so using which we draw our conclusions. Next. So the temporal variability in water level and climate variables in Tamil Nadu state are presented in this picture, and we see that there is sufficient variability over time in terms of maximum temperature, minimum temperature, rainfall, and also the water level available in the groundwater. Next. So here we present the major results of the study. The first objective or the first part of the analysis relates to the impact of climate variables on water table. So here we are presenting important results only. We have several variables included in the analysis, but the important variables are the rainfall and the lagged rainfall. say they both affect one period lagged rainfall as well as the current period rainfall have significant impact on water table variation. But more than that, if you look at the impact of temperature and the electricity subsidy on groundwater table, it is more as compared to the rainfall impact. Say for example, the rainfall marginal impact of rainfall is only 0.00074, whereas for a marginal impact of 1 degree increase in maximum temperature leads to 0.2 meters of fall in the water table. So, water table falls by 0.2 meters if the temperature increases by 1 degree. Similarly, in recent times we have 100% electricity subsidy for groundwater pumping, which has resulted in over pumping of groundwater, which in turn leads to a lowering of groundwater table. Next. So, here we present the results of the impact on farm income. Again, as we found in the case of Saboor's study in Pakistan, rainfall and temperature have non-linear impacts. So, as temperature increases, initially the farm income increases and finally it starts decreasing. So, beyond of temperature, the farm income starts decreasing because of negative impacts caused by existing quantum of water, and then interval externality resulting in the reduction of net farm income. The higher depth to water table reduces the farm income. Table goes on increasing, that means water level goes down, starts decreasing because of the farmers' inability to water from the deeper aquifers. And then electricity subsidy, which is earlier policy variables in this analysis, it increases farm income. Farmers are able to pump water freely without paying any market costs. Next. Farm income is reduced as a result of increase in temperature. Electricity subsidy is leading to increase in then over exploitation of groundwater is a major increased energy consumption for groundwater extraction is another major economic concern. Then reduced area irrigated per increasing number of wells, the area irrigated by each well resulting in diseconomies. Then free electricity combined with drip irrigation and coconut crop, which is a water intensive the state, lead to a lot of groundwater over exploitation. It's a very important policy concern for our state because of then it also causes intra and intergeneration in the sense that the more number of wells are farmers or small farmers to go out of agriculture because they cannot bore wells because it is very capital intensive. So that way also. Next. So we have some next. So next. So the ways forward, the crops is necessary because planting of leads to groundwater exploitation, and then remove or reduce, especially for the large farmers because they are subsidy for digging deeper and deeper wells, thus depriving their share of groundwater. Then public investment in groundwater recharge should be enhanced. Conservation technologies and strategies should be promoted. So, important policy recommendations. Next. Yeah.
Good.
Thanks. Next we pass on to by Prabath Edirisinghe. He is from Integrated Development Association. He is going to talk on the slash and burn and the related issues.
I'm going to talk on slash and burn agriculture, socio-economic and environmental consideration. Next slide, please. Burn cultivation is a very around 3 to 500 million of the people of the world, right? This practice slash and burn cultivation. This practice is in short term, but there are a lot of environmental and ecological activities. Many people try alternatives to slash and burn cultivation, but these will fail because of poor understanding about the farmer's decision. The slash and burn cultivation have some negative impact. So climate deforestation contributes to 12 to 20% of greenhouse gas emission. Main reason is that the carbon sequestration of the forest, the carbon sequestration of the other land uses like and forest fellows and other land uses. Therefore, when forest land use is converted to another land, of the carbon dioxide has concentration increase. That result climate change. And forests are very highly vulnerable to climate change. The deforestation and forest degradation impacts on climate change. That is, it increases the climate change and it increases the vulnerability to climate change. Next slide. Sri Lanka, many in dry zone of Sri Lanka, many people cultivation. But in addition, in Naragala district of Sri Lanka, which is many slash and burn cultivation intensively done. Last few years, percent of the forest area have been deforested in the district. Is slash and burn cultivation, and these people come to forest and they clear slash and burn. And in addition to that, cultivation, natural regeneration is disrupted. So, therefore, slash and burn cultivation contributed to deforestation and forest. Next slide. To find out alternatives for this slash and burn cultivation, we the alternatives and as well as determinants of slash and burn cultivation. We try to understand the socio-economic determinants and the feasible cultivation. In Munaragal, there are people, around 52% of the people practice slash. They are not very poor people. You see, if you see, it is around 1.2 hectares per house. They have paddy lands, they have homesteads, they have the uplands like lands belongs to uplands. All these lands are 1.2 hectares of, and the housing condition. Many of the people have electricity, and they have, and the schooling, the education is. Next. When we study the people who slash and burn, the area under slash and burn cultivation is around 8 hectares. But many of the people have land. So therefore, they have one parcel of land. They cannot, shift from one to one place. Other people can, but only 94% they cannot maintain very short fallow period around 6 months. In addition to that, we have found out around 10% farmers come and they have done new areas and cut forest and dead. And these people, these slash and burn traditional farmers, they have used fertilizer. And the gross income season is around 62,000 rupees. Next. Slash and burn farmers and non-slash and burn farmers have more lands. They have more lands. They have more paddy lands. They have more. But non-slash and burn farmers have less. The annual income. When we study the non-farm households, the non-farm income non-slash and burn farmers. That means the slash and they like to rely on the other income sources like labor, and they are not, they don't risk of practicing like that. They do, but they go for other areas and they labor labor employments extra. Then when we understood that, if the people have more land area, these people cultivate more slash and burn lands. The number of, they have more family members, lands, they cultivate more lands. Slash and burn cultivation. If the people have to go home to the slash and burn area, the operational cost is high. So these people, so these are, and the other thing, if the people have, they cultivate less. The age of the household is higher, they cultivate slash and burn area. And the population density is high, they cultivate less slash and burn area. And we found out the alternatives. Of the people like to quit if alternative is provided. And we let the alternative irrigation agriculture. If the irrigation, they like to quit slash and burn. In addition that, we improve farming. Uplands, yes, their own lands of upland. If somebody helped to improve, like to give up slash and burn cultivation. And farmers will quit slash and burn. They provide alternative upland farming, and if we can opportunity cost of labor, then people non-farm income sources, then they don't go for that. To do this, we can provide good alternatives. Food production can be, climate change problem will be protect forest for conservation.
By Kishor Goswami, Institute of Technology, Kharagpur, on the biofuel policy of our plantations.
Thank you very much. I am going to take a clue from the presentation. So in his presentation, he was relative to slash and burn. To switch over from slash and burn to other alternative. At the same time, the irrigation, but most of these areas are highland, so irrigation may not be a good or not, because it may not be cost effective. Here comes that one option, that is your say promoting maybe some crop in those areas where water requirement may be constant. So as we know, along with that, our development, mostly we are talking about energy security development perspective. So in the near future, will be more and more. Here that change or climate friendly crops growing up, friendly crop for energy security. Important. At the same time, we cannot ignore. So here comes that policy dilemma. Or should we give more emphasis to food? At the same time, is there any other possibility energy security through growing some alternative, which even reduce even slash and burn environment friendly, and so I try to highlight some of that policy. So this is we talked about the climate friendly, growing climate friendly crops, growing some agricultural. Demand for biofuel is increasing. Of biodiesel and your of ethanol is mostly your wheat or maybe other crops, agricultural crops. Source of biodiesel, commercially grown biodiesel, they may increase because it is called climate friendly. Say sulfur dioxide, and it is having many other. It contributes in the context of India now almost petrol and diesel. It's now from Middle East. It has a generation also, maybe some plantation or biofuel crops. Food security, next one. Food because of demand for growth and income growth. Many of you are aware about that recently announced that guarantees 5 kg of food. So demand for food grain is going to in near future. Actually, where is that one? This is that demand for biodiesel be 10-15 years up to 2 landing level is 5%, 10% level, where without modifying our blending we can go for mostly biodiesel for Jatropha. Now if we look at these different studies, global arable land devoted for biofuel is going to increase up to 4% by 2030. There may be a conflict with respect to allocation of land. This is a policy measure. Second issue is that decrease and price increase, because if we convert production, there may be every possibility of production. At the same time, then price will go up. The one, it may not be favorable for many others, but one that farmers who are growing food crop may be agricultural price. Maybe another issue to be debated. So that that conflict we can reduce it by agricultural productivity. That may be second option may be better land management, and third generation biofuel. So when we talk about first generation, second generation, or third, first generation means growing of that kind of consumption, like say corn. First generation. Second generation, tree-borne seed like Jatropha, mixture of Jatropha. So here, the process of esterification and biodiesel, and 90% no modification of a requirement. Straight away you can mix it. Biofuel, which we started giving more emphasis, of maybe biodiesel or maybe biofuel from other kind of product. Now our the production of Jatropha actually going to reduce food. So at macro level we will find or maybe such kind of report that talks about okay, it is, or maybe biofuel, it is going to say food production. But at micro level, at farmers level, what actually study is actually done in 6 villages in Assam and Arunachal Pradesh. So here it's from northeastern states, because 9.5 is out of India's total wasteland available here. So such kind of crop in wasteland or degraded, through which we can reduce that conflict. Region of selecting this northeast total area is observed. If we look at these other parts of India, parts different Jatropha processing, Northeast India was totally untouched. 2006-7. So Jatropha was included in the region in 2006. One of that advantage, or included today's morning session also, many people slide and many other issues may have it, particularly in hilly where forest is already degraded, give a green cover that may environmental disadvantages you may get it. Next slide. So here we found that average farmer's age is 7 or 8. This is just some descriptive. 7 to 8 years of education on 1 hectare of area under Jatropha. Percent of them converted agricultural land converted agricultural land to Jatropha. Few farmers who converted for Jatropha plantation. Both these farmers, they has grown Jatropha for on an average. So here basically we made an to see why farmers are, how this growing of Jatropha is going production. Here ultimately means two important factors: diversion of land from agriculture to production. Another is diversion of Jatropha production. So here increase if we convert, increase the probability of food crop decline. Second one is if we probability of food crop decline by 80. So along with that there are other factors also, diversion of land and diversion of labor. The next issue are heading from these two of Jatropha growers are current already abandoned. So two categories. So it shows that there are significant differences of farmer with respect to conversion of land as labor. Next slide. Then related to found that farmers, I am say individual maybe in other professions, we that farmers are to convert crop land and divert relative to non-farmers. That is our. But hired or family labor in land conversion. Farmers offer lower risk with respect to 15% from crop to Jatropha and 20% it should give us that this might be one of farmers switch over from food crop production, because here current farmers are in comparison to past farmers, and many of them abandon this Jatropha plantation. Below here we identify few low price of Jatropha seed, absence of continuous flowering, some of that problem. And last slide, way forward. Reduce food production in short run, long run. So in long run, we should not whether this Jatoba plantation is going to, if it is much more profitable, then there are incident farmer even switch back to food production from Jatoba. The last point is that whether learn intercropping or second and food versus viable. Right, this is just some picture of algae. We may concentrate maybe to reduce fuel conflict. We can depend biofuel instead of first generation. Thank you very much.
And now presentation of this session. Sharma, he is from Tribhuvan University and he is perhaps quite a different red plus market instrument for climate.
So I am going to talk red. So the seems clumsy term. R refers to reducing emission degradation. So actually climate change mitigation strategy. Climate change is occurring higher emission in the atmosphere. So if the carbon dioxide concentration in the some means, then be reversed. So there are different methods this carbon dioxide concentration. A new innovation which high emitting methods, and another very important method is trees, because the dioxide from the air in the carbon is stored in the trees, so carbon dioxide in the air. So the paying for environmental emitting countries, developed countries, developing countries who grow for the station service, environmental service. Actually, about 2 experimental projects are of the world, and one experiment, and I am going to discuss this red piloting in Nepal. Next slide. The mechanism is measure the tree, etc., and what is the stock in the forest every year. That increment in the carbon make claim in the international increase our carbon stock in the forest by payment for the generally $10 per ton, $20 per ton. So as the price increases, there is more incentive. So actually India had this million hectares. This ton per hectare in the forest is, Nepal has this 36,000, that is the ton per hectare. So in terms of and forest coverage, Brazil is attractive destination for this. Have huge forest cover very high. So this mechanism that is more targeted deforestation and degradation in, but developing Sri Lanka, etc., can also mechanism because they are without red also be an additional. So this so this pilot is being done, that community forest user groups are the carbon stock they collect every, and they are being paid for. It is not a market already established, but so communities are paid carbon they sequester. So experiment try to see by does carbon stock increase in the forest greater than the business, and another is by people the money for the carbon livelihood, and does it improve? So that is whether there is economic impact or not, and whether the forest is the result of this carbon payment or not. Aspects that this experiment has. So next slide please. So actually every year measure the carbon are technical formulas. So the payments are made. Payment is 40% social. So not only this payment, but also on other social sectors. Poor people in the community, then more carbon price is paid to the community. These are the adjustment made. Paid to the community that for income generation activities, for awareness and training activities, and if you like biogas, cooking stoves, etc. So happened what has been. Now we have to see on this payment, and based on this expenditure have taken place in the community. We did an experiment. 7 with RED program and 7 RED program, and see what we implement a RED. We do not use this incentive economic to see what will be the forest for RED, what will be the social welfare for the RED versus non-institutional this characteristic for RED versus non-RED experiment that was done. This method. Next slide, please. So we 2011 as a base, 2013 as a end. We will see what changes take place in the institution forest. So this is some districts have, while some has. We are going to see at the end of what changes in the carbon stock will take. Carbon stock change will. So we'll see whether really. So next slide. So how much firewood they collect? How much leaf litter with RED and without RED. This experiment is in the form of carbon payment collection or not. We'll see that. Right. 2011 we so actually there is no difference in the size, literacy, per capita consumption. That is both. Actually this was made the RED and the non-RED community with propensity score matching statistical. So selected very similar type of community forest to see the. There is some difference in the firewood dependence. There is some difference in the forest line, but we have to see what in line. So between these two, actually that will matter. No. One. So we now what? So this monetary incentive more efficient, more this better in terms, because this community forest through a long process of this, because earlier the government property, now they have been to the community. So now if this incentive will work or not. So in terms it has been found that indicators have improved in the rate compared to the non-community forest. This how in the governing community, what is the number of indigenous groups? So what number of meetings have performance the indicators, and based on the rate of refugees. Next slide. Expenditure rate payment has gone households in the community. On that, the storage of the expenditure, we see has benefited most. Socio-economically, the Dalits have a greater access to the rate. So there are institutional development, government. So data is come into 13. So in the first households at the end, we'll see that what change, but based on this prudence, really, and mechanism, whether it is going to be successful in the Brazil, which have a, whether it will be possible for the India, or because so if the benefit, if there is a benefit, viable. So as a mitigation. So ultimately, the carbon for carbon, whether there is an increment, if there is no increment in the carbon, this no payment is going to. Basically, it depends on we are going to see after the inline. Existing community forestry institute sufficient to handle this rate, that the mechanism that is sufficient to handle based on this thing. So, okay. Okay.
Yeah.
Okay. And another problem is a very technical issue.
Yeah.
Measurement use the community, because communities are not very literate, so again have to go to the government, lead to more centralized management, because this is better for forest, lead to more centralization issue. So
Good. And she was at
I think it's
yeah, rather from red tag, because got red.
oh
Okay. So questions to Ed. Yeah, please. Yeah, right.
Started carbon.
Yeah.
This is one question.
Yeah.
My second question was interesting. Is your an analysis pilot project? Have you tried? You said that the marketing was not all the revenue. Anyway, have you tried to marketing and to bring to the cultivators? The next question, friend from I was mostly the water. Everybody. Pakistan flood. And I was wondering, this flood, where does it come from? Is it glacier lake or is it first? Or you have rain somewhere and water flow. This is seek some clarification. And before I forget, water. Your groundwater in Madras area. If you get more water from Karnataka, would it reduce the pressure of water and to what extent? Groundwater at any stage by problems. And if so, how much? And maybe I don't want to leave him out. And the slash and burn. We also have slash in Bhutan, but what they do is that they have large slash and burn, and because they find it's not no more productive, and they let the bush grow. But now with it is also growing, it seems to be more somewhat slowly, frequently. So that's alternative because we're burning it. Whenever there's a rain, there's a land. It's gone because we have forest is gone, forest is burned, enormous of forest fire, and because of flash burn, apart from the emission, is bad enough for our health. We are, of course, as I said, we are trying to enlarge the areas of forest areas, but that necessarily the agriculture production. We have to somewhere. And you could find to move your slash and attract it somewhere else, an industrial area, to then staying on farm, and or private could the slash and burn area comes in. Thank you.
Okay. Any more questions? We'll take all the questions and then. Okay.
I have job once you have comparison with 26, the conclusions you have issued. Based on these conclusions, what are your recommendations for the public policy prescriptions? What sort of policy interventions can actually help us to face this eventuality? Number two, the situation which we are observing, what sort of initiative private sector or the community can adopt to mitigate the effects of climate change in Punjab particularly.
Any other question? Okay, now the same pattern as that of. So let's start with Dr.
Working. Hello. Okay, thank you for the. I mean, how the flood comes in Pakistan directly related to my study, impact of climate change culture. But 10 flood is concerned. This I collected 2012. Obviously, that was in my mind. There has been a flood in 2010. Key reason, the key reasons. One is, as you have already mentioned, huge melting of ice or glaciers. So there was a continuous melting of glaciers for the last couple of years before 2010. The bulk came in 2010. Important that started in 2009. That is the pattern of rainfall. I mean, the monsoon which is several months. That is the whole of 80-90% of the in 2 weeks. So that was the third reason I would to link it to the weak disaster management system as far as the flow and drainage of whole water is concerned in Pakistan. Had there been a good management system, this water management system in our country, at least the extent of flood could have been cut. As far as the policy lesson is concerned, I think, as I have mentioned in my last slide, that the public policy that needs to be seen from 3 different angles. The one important thing is research. Unfortunately, I would say that as far as the branded research is concerned in Pakistan or in most of South Asia, as climate change is concerned, that research is lacking. So we need to strengthen our research institutes, and that strengthening can be made in a partnership with the sector. As we see in USA, the private organizations, they collaborate with the sector research organizations, and if we make this sort of collaboration, then obviously that would be a sort of win-win situation in the years to come. As far as the institutional framework of research institutes in Pakistan is concerned, that framework is very good. The only thing that is lacking is the paucity of funds. So we don't have enough funds to continue the research process, because the work I have done and the work we all people have done in different countries, there is a need to continue this work and to rigorously check or replicate it again and again in different scenarios. So then finally we conclude, yes, this is the policy here that can be made. Then other thing that is quite workable, and I have checked it in my sample data, that is the diffusion process. So the farming community, particularly large farmers, I mean, the approach I have used is the Ricardian approach. The simple thing is this Ricardian approach incorporates adaptation automatically in the system. So what I have seen that the large farmers who I mean are enjoying a good level of net farm revenue, the reason is because they are adopting. So they have a good capacity to adopt. On the other hand, small farmers, they are ignorant, they are not well informed. So the our extension service and the diffusion of knowledge, that is very important. The structure is already there in all the South Asian countries, including Pakistan.
but the need is to mobilize that structure. Again, in that structure, in some countries, there is a practice that the extension services that are provided through the collaboration of international companies, like some of the pesticide companies, they collaborate in this regard. So if we mobilize some of the international companies like fertilizer providers, pesticide companies, if they join hand with government and they play a role in this diffusion process, so there should be a sort of regular information to the farmers about the weather data, or met sort of information should be available to the farmers. So if the information is available to the farmer, either through public sector or through private sector or a joint venture, then I'm quite hopeful that they have good resilience to adopt on urgent basis. So that is my point.
I think.
Yeah, Mike. I think I have two questions from our colleague from Bhutan. One is on the presence of arsenic in Tamil Nadu's groundwater. We have not yet come across any arsenic problem in Tamil Nadu. So there is absolutely no concern of arsenic pollution in our groundwater. The second question relates to the release of water in Kaveri river from Karnataka and whether it will mitigate the problem of groundwater. So one thing is that in the past as well as in the present, the Kaveri river water does not have any big impact on groundwater supply or groundwater demand in our state, because most of the groundwater developments are taking place in other parts of the state, not exactly in the Kaveri river basin, because Kaveri river basin is already having a lot of water from Kaveri. But in the future, there is no chance or no opportunity for water release from Karnataka to increase. It will only decrease over time, because there is a lot of water that is being diverted to other purposes in Karnataka itself. And also within Tamil Nadu, we are diverting a lot of Kaveri water for other purposes like industry, drinking water purpose and other things. So there is absolutely no chance for any increase in the water supply from river Kaveri. So that is not going to in any way mitigate the problem of groundwater, and that is it. Yeah, thank you.
At present, we don't have any program to move farmers from existing locations to industrial areas. But instead of that, what government does, government go to these lands, villages, and implement some livelihood development programs. That is what the government will do at present. They don't move, they don't take people out from the areas.
Yeah. Sure. Related to that pricing policy in the context of Jatropha or market structure mostly. So to some extent in Indian context, I find that it is government policy is little bit misguided, because in India, biofuel or biodiesel price is artificially low. It is around, in Indian rupee, around 26 rupee 50 paisa, whereas normal diesel price is around 54 rupee. That is after subsidy. If you remove subsidy, it may go up to maybe more than 60. So this is not a level playing ground. In one side, you are artificially keeping a biodiesel price at 26 rupee. Other side, you are giving subsidy to diesel and keeping it maybe around 54. If you increase say biodiesel price up to say 50 rupee even, it will be much more incentive for farmers, because you require 3.5 kg Jatropha seed to produce 1 liter of biodiesel. I made that kind of analysis also, which I didn't present it here. So in that process, to generate say 1 liter of biodiesel, our actual cost is around 67 rupee. But if you add their value addition, it comes down to 49 rupee. That value addition itself is inconclusive, because recent findings say, because Jatropha leaves are much more valuable. So this trend is going to come in near future maybe, because many private companies are taking initiative to use Jatropha leaves for using as a base material for different creams. It's a very valuable product. So in that way, even Jatoba price may come down, maybe even less than maybe 30 rupee. This is one issue.
Is it the artificially kept low, and who is footing the bill?
It is government is artificially keeping it low.
And the
Now
government is paying the subsidy on that.
Or in diesel or biodiesel?
In the biodiesel.
Biodiesel no subsidy.
No subsidy.
It is only 26 rupee 50 paisa, 27 rupee suppose. But in case of diesel, which after subsidy it is around 54. This is one issue. A second issue is about private players here. Private players were there, they were taking initiative like Magor Group, Williamson and Magor Group, Sun Plant Agro, mostly in South India, Smriti Hub. So many plants were there, they were taking major initiative, they were distributing seedlings free of cost, they were collecting seeds after harvest. So that kind of provision was there. But unfortunately, when these companies are running with loss, how long they will sustain? So they need at certain stage maybe some sort of support. So public-private participation is partnership is very, very important.
I hope you would encourage this more in Arunachal Pradesh. We have some slash and burn problem there. Instead of slash and burn, they can cultivate more Jatra.
I think Bishnu ji
Yeah.
has
The
some answer.
question on this rate is, has Nepal started this rate, started to receive rate payment or not? So actually, Nepal has not gone into because this rate is still undergoing a process, and there has been no agreement internationally about the prices. So there is some CDM mechanism going on,